All right, so welcome to this lesson. Yeah, so before we start solving tutorial questions, I think I'll first start by introducing you to logs and making sure at least that you understand some of the rules to logarithms and exponential functions. All right, so let us quickly begin. Okay, so if you have any questions or you need any help in mathematics, chemistry, and physics, feel free to contact me using these lines on the screen. Okay. So the first question is this one, but like I said before we start, before we can start looking at these questions, let me first start by introducing you to logarithms. Okay, so let me add a new page, which is just going to be a blank page where I'm going to talk about logs. So I'll put it here. Okay. All right, so this is, I'm going to start first by taking you through the rules of logarithms. So the first rule that we're going to look at, use white. Yeah, so first thing that you need to know is that there are two things that we usually use, or we can denote, or we can show, or we can discuss logs using two different ways. So logs, the first one is the log itself. Let me start by giving you the rules to logarithms here. So the first one is the log itself. So this log can be written in a format as, okay, we can have maybe log A, and then we have this subscript here. So this subscript is the one that we call the base, and then this can also be written as, in a short form, we can write this as LG. So in some books, you find it written like this. In other books, you find it written like that. So this will simply be talking about the same thing. Whether you see this or you see that, it still talks about the same thing. And then apart from that, we also have what is known as the special, we also have what is known as, or we also have a special logarithm, which we call the ln. So whenever you see ln is also a log, and it obeys all the rules of logarithms. It obeys all the rules of logarithms, and it's just a special logarithm. Yeah. So for instance, if we say ln A is simply just a log of A with a base E. So in other words, the definition of ln is a special logarithm with a base A. So any logarithm that has the base E, rather, any logarithm that has the base E is called a ln, or it's a special logarithm that we call ln. So if I have, let's say for instance, log 5 base E. So log 5 base E can also be written as ln E. Oh, sorry. It can also be written as ln 5. Ln 5. So log 5 can also be written as ln 5. Ln 10 can also be written as log 10 base E. So this is the first thing that you need to understand as we begin to look at logarithms. Okay. So let us now also discuss the rules. So the rules of logarithms, the first rule that we're going to look at is if you have, or let me say, the log of 10 is equal to 1. Why do I say the log of 10 is equal to 1? So the log, if log has no base here, so if you don't have any base here, it means that the logarithm is in base 10. So this log, or what I mean is, if you have log 5. Log 5 is just the same as log 5 base 10. That's what I mean. So any logarithm that does not have any base here is simply in base 10. It means that it's in base 10. And if you have a log of 5 base 10, this is just the same as log 5 over log 10. So these are some of the simple rules that you need to consider as you solve any question on logarithms. Okay, so log 5 base 10 can also be written as log 5 over log 10. This is how we convert the logarithm from one base to another. So meaning if you have something like log, you have log 20 base 3, you want to convert this to base 5. You simply just write log 20 and you say over log 3 and you change it to base 2. Since you want to convert it to base 2, you put your base there. So this is exactly what you're supposed to do when you are changing a logarithm from one base to another. Okay, so we have learned, in the first rule, we have learned that the log of 10 is equal to 1. And the reason why we are saying it's equal to 1 is because we know to say a log that has no base here is simply in base 10. So when we say log 10 is simply just the same as log 10 base what? Base 10. And hence, if a log can be written, if log 20 base 3 can be written in this format. Okay, let me give a different example here. So if log a base b can also be written as log a over log b, it means that even log 10 base 10 can be written as log 10 over log 10. So when you divide log 10 by log 10, the answer that you're going to get is simply just 1. So this is the reason why we say log 10 is equal to 1. So some lecturers would ask you to prove that log 10 is equal to 1. So this is the simplest way or method you can prove that. Okay, the other rule that we're going to look at is if you have ln, remember I said ln A is simply just the same as the logarithm of A base E. Now imagine if we say ln E. What is ln E? So ln E is simply just, so ln E is equal to 1. So ln E is simply just equal to 1. Why am I saying it's equal to 1? Let us look at this. So if we say ln E, so if we say ln E is equal to, if we say ln A is equal to log A base E, it means that ln E is going to be equal to log E base what? Base E. And whenever you have this in logarithm, this always gives you a 1. Why? Because you can write this as log E over log E. And log E over log E, this will give you 1. So this is where this one is. We move on to the third rule. So this was the second rule. We move on to the third rule. So the third rule, we're going to employ this same part here. So whenever you have any logarithm that is in the format log A base A, if you have this, if you have the base and what you have there is the same, it means that the answer is 1. So whenever you find anything that is in the format log 2, or whenever, for instance, if you have a question which says log 2 log base 2, if they ask you to find the value of log 2 base 2, the answer is 1. Log 6 base 6, the answer is 1. Log 7 base 7, the answer is 1. This is the reason why we say log 10, the answer is 1, because there is always a base here if this part is empty. So if we say log 10 base 10, this has to give us 1 as well, which is the case which I talked about. Okay, so we have talked about 3 rules now. Yeah, so I've talked about 3 rules. So we proceed to another rule. What happens if you are adding 2 logarithms? So, okay, before we go to the addition of logarithms, let's look at the fourth rule. So the fourth rule is if you have, let's say, A, and then you have log B base C. This one can also be written as, log B to the power A, and then the base C there. So what I mean is that if you have 2 log 3 base 5, this can also be written as what? These 2 can go and become a power of 3 there, and hence this will be log 3 base 5. Of course, the 2 will go up there, and then it will become the power of 3. So the other thing that we can look at here is, okay, first let me give one more example on this one. What if you have been given a question which is like log, you have a question like this, huh? You have log 8 base 2. How can you solve this? They ask you to find the actual value of this logarithm here. How do you solve such a question? So this one is simple and straightforward. What do? So we are going to say this is equal to log, this 8 can be written in terms of the base 2 as 2. Okay, before I do that, 8 can also be written as 2 times 2 times 2. And we have the base 2 there. So this 2 times 2 times 2 can also be written as what? 2 to the power 3. And we have the base 2 there. So these 3 can come down there. So the same way we can take these 2 up and become a power there, it can also drop down there to become a coefficient there. So we can have, this can also be written as, so this 3 will drop down to go there, and this will become 3 log 2 base 2. And this log 2 base 2 there, remember what I said, anything that is in the format log A base A, as long as this part and the base they are the same, is always equal to 1. So this part here becomes what? 1. So we can write this as 3 times 1, and the final answer becomes 3. Hence, log 8 base 2 is just equal to what? 3. It's as simple as that. Anyway, we'll meet such questions as we progress. So let's look at the fifth rule. What happens if you are adding 2 logarithms, or how do you add 2 logarithms? So you can only add 2 logs if they have the same base and they also have the same exponent. Okay. If they have the same base and not really exponent, okay, let me write the logarithm here. So if you can only add 2 logs, okay, let me give 2 examples. We have maybe log A base 2 plus log B base 2. Yeah, so these 2 logarithms, cannot be added unless we have A here. Okay, let me do this. Let me show you something very important. Okay. Okay, if you are adding 2 logarithms, in short, you simply just multiply what you have there. This is what I wanted to write, to say. Okay, I wanted to erase something. Okay, let me just do this. So log A base A, log A base 2, if you add it to log B base 2, this is simply just going to be log, you multiply A and B there, and you have something like this. So A times B, you have A, B, and then the base there, you leave it the way it is. So this is how you add 2 logarithms. Then when you dividing, rather when you are subtracting 2 logs, if you have, let's say, log A base 3 minus log B base 3. If you're subtracting 2 logarithms, what you have to do is just to divide what you have there. So this can be written as log A over B base 3. So these are the most important rules to logarithms and exponential functions. So the same rules that I've shown you here, they all apply when you're dealing with ln. So what I mean is that if you have ln A plus ln B, this one is just the same as ln A times B. If you have ln A minus ln B, this can also be written as ln A over B. This is what it means. Yeah, so the same thing, all the rules that apply on logs, they also apply on ln functions. All right, so let's quickly start solving questions. So we have this question here. So I've been given to say, okay, I think I've forgotten one thing. How do you convert a logarithm to an exponential and an exponential to logarithm? So it's very simple. So how do we convert? So how do we convert? It's very simple. If you have y is equal to log 5 base 3, how do you convert this to log to what's this to an exponential function? So you have heard me mention that whenever I'm writing any logarithm, I'm saying log 5 base 3. So whenever you're converting to exponential, this same 3, I'm saying base, it always just remains as a base. And this one here becomes a power. And then you say this is equal to what? 5. So we have converted to exponential. So if you have another example here, let's say you have x is equal to log 7 base 2. The base will still remain a base, and then this one is the power. And then we say this is equal to what? 7. So now how do we convert this back to logarithm? The base remains the base. So I'm going to say, okay, we say the power, which is the exponent, the power there, we say x is equal to log 7, and then the base will always be the base. So it will still remain the base even in logarithm. So it's as simple as that. Let's quickly move on to solving questions. All right, so we have the first question here, which says, given that, given the function f of x is equal to, so we have f of x is equal to 1 over 16 to the power x, and then evaluate each of the following. So they're asking us to find f of -2. So whenever you've been given a function and then they tell you to find f of something, it means that while there's x in that function, you have to replace with the value that you have inside the f of. So when you have x there, if we say find f of -2, it means that x is equal to what? It means that x is equal to -2. So meaning in this function, while there is x, I'm going to replace with -2 there. So I'm going to have 1 over 16, then I'll put -2 there. So what this means, remember the rules of exponential functions. I would have also gone through that for the sake of revision, but anyway, I'll be doing that even as we solve. So I just went through the rules of logarithmic functions. I think I'll also be explaining the rules of exponential functions as we proceed. So if I have a to the power -2, a to the power -2 is simply just 1 over a to the power 2. So this is the rule that we're going to use here. So if we say 1 over 16 squared, 1 over 16 to the power -2, this is just the same as saying 1 over, we have 1 over 16 there, 1 over 16 there. Then we raise everything to the power 2. So what this means is that if you divide 1 divided by 1 over 16, you are saying 1 divided by 1 over 16. This one is just the same as 1 times 16 over 1, which gives you what? 16. So this part is going to be replaced with what? 16 there. And this will be 16 to the power what? 2. And 16 to the power 2 is simply, I think, 256. Should be 256. Yeah, so 16 to the power 2 gives you 256. So this is the solution. We move on to the next question. So this one is also simple. We're saying f of negative 1/2. So in that same function, while there's x there, I'm going to replace with negative 1/2. And this will become, so we say f of negative 1/4, not 2 rather. So we have something like this, 1/16 raised to the power negative 1/4. So what this means is that 1/16 will flip again the same way it did here. So because of this negative, means that we're going to have 16 raised to the power 1/4. And then in exponential functions, whenever you have, let's say a number a raised to the power 1/b, this one is just the same as the bth root of what? Of a. That's what it means. So if we have 1/16, it means that, if we have 16 and then we have 1/4 as the power there, it means that we're going to have what? 4th root of what? Of 16. And then the 4th root of 16 is simply just, so the 4th root of 16 is simply just, it should be 2, because, because 2 times 2 times 2 times 2 gives us what? 16. Yeah, so the 4th root of 16 gives you 2. Move on to f of 0. So f of 0 is equal to, so we have 1/16 there, we put a 0 where there's x. So any number raised to the power 0 is equal to 1. Any number, any letter raised to the power 0 is equal to 1. So if we say x to the power 0, the answer is 1. 50 or 20 to the power 0, the answer is still 1. So that's the answer for C. We move on to the last part there. So we have the function f of x is equal to 1/4, or 1/16 rather, then raised to the power 1/4. Where there's x, we put 1/4 there. So if we do this, this is just the same as 1 to the power 1/4 over 16 to the power 1/4. So what this means, or what I'm trying to explain, is that if you have any function a over b raised to the power a fraction c over d, or raised to the power any power here, we can have c there. This implies that this c will be raised to the power a, and then it will also be raised to the denominator there to be b to the power that same c. So this is what I've done. I've just distributed the power to both the numerator and the denominator. So anyth root of 1, the answer is 1. And then the 4th root of 16, the 4th root of what? Of 16, we said it's 2, and hence you have the solution to be 1/2 there. Okay. Okay, so we have this as the answer. Let's quickly move on to the next question. Let's move on to the next question. Okay, so this is the next question that we have. So this question is simple and straightforward. It also talks about exponential functions and also some logs here. So the logs that we have are simple. Okay, so we have these logs here. Exponential functions and logarithmic functions here. So the first question is 3 to the power x. So we have 3 to the power x. Okay, let me just start recording a new session.